Excellent. Well, I think we're going to go ahead and get started here. Welcome to today's SCM Connections web seminar, the S&P Optimizer, How to Approach, Manage, and Maximize the Benefits, presented by three of our partners and solution architects, Claudio Gonzalez, Sanjay Jalagi, and Mike Raftery. If you have any technical problems during today's session, you can send a message to SCM Connections or the host, and that'll come directly to me. You can do that via either the chat panel or the Q&A screen, and hopefully we can get anything resolved there. Our presenters will also be taking questions at the end of today's session using that Q&A panel found on your screen. So if you can just hold off on questions until the end, that would be great. We're going to go over our agenda here in a minute. You can kind of see here what we're going to be looking at. We're going to introduce the company and the presenters. Then we'll be talking about the S&P Optimizer overview and use cases. That'll be with Mike Raftery. And then we'll be talking about the approach, how to manage and maximize the benefits. Sanjay Jalagi will be handling that part. And then Claudio Gonzalez will be wrapping us up with master data, profiles, and logs. A little bit about our company before we get started here. SCM Connections is a supply chain management consulting firm, and we specialize in advanced planning and optimization. If you want to check out a little bit more about who we are and what we do, the people, process, and technology that we use, you can go to our website, scmconnections.com. We don't have a ton of time here, so we'll just get to our presentation here. Our presenters, each of them, they're partners and solution architects at SCM Connections. They each bring 13+ years of SAP experience, 10+ years of supply chain experience, and they do specialize in the optimizer. Claudio Gonzalez is the #1 ranked speaker at multiple SAP Insider events, and he's a recipient of the SAP Service Excellence Award for Outstanding Consultant. Claudio's built a reputation as a speaker, implementer, and solutions architect in SAP APO. Sanjay Jalagi is a founding partner at SCM Connections, and he brings global implementation experience to our company and to his clients. He's implemented solutions in the USA, in Brazil, Switzerland, Italy, and France with responsibilities for design, development, and implementation of global templates. And in addition to being a solutions architect, Mike Raftery is also an industry expert and thought leader for strategic direction and continuous improvement of consumer product supply chain planning processes. And if you've read any of our blogs, chances are pretty high that you've read a couple of Mike's. So that is the guy behind our blogs there. And before we get started, we're going to just kind of see who's in the room. We are going to launch a quick poll here. And if you can actually pull up on your polling screen, you should be able to answer one of those questions here. What's your primary role in your organization? A, consultant, B, supply chain leader, C, supply planner, D, other. We'll give it just a few seconds here to get that one answered. A few more here. And we've got a couple of latecomers here, so we'll get those answers in. Okay. And it's closing out here, 5 more seconds, and then we will throw those answers up on the screen. Great. Okay, and I'm actually going to turn control over to Mike now. He'll give us a little overview of what's going on and who we have in the room, and he'll take it from there.
Thank you very much. Hi, I'm Mike Raftery. Thanks for the introduction, Megan. Been doing Optimizer for quite a while now, and familiar with what I can and can't do. We're not here to tell you it can solve every problem, because that is not true. What we can do is tell you what problems it does solve, what it doesn't solve, and then get into how it does all that magic. There's a lot of kind of fear, unknown about the Optimizer. It's seen as a black box. There's not a ton of information out there, and the reason is that everybody sees it a little bit differently. So we're going to go through a couple of use cases that we're most familiar with, but that doesn't mean these are the only use cases out there. Again, it's a very flexible tool, so there's not, there is no usual implementation, I would say, of the optimizer. So overview of what it is and the use cases behind it. So what we're going to go through here is through the whole presentation, we're going to look through when do you need an optimizer and when would you not need one. Because it is not something that is just plug and play, like I mentioned. How you size it, how you model costs, and then deep dive into the technical bits and bytes behind the solution. Just a little bit of background, both detailed scheduling, or the PPDS part of APO, and the SNP side both utilize optimizers, right? So there's an optimizer button in both of those applications. We're going to focus on the SNP optimizer. So that looks like bucketed planning. It looks like medium to long-term scenarios, sourcing, what ifs. PPDS optimization is generally thought of as scheduling. So how do you get the most efficient schedule based on setup costs for your planning board itself. The SNP optimizer is going to be using the planning books in APO, and that's what we're going to look at today. So what is this thing? So an optimizer is a mathematically driven solver, an engine. Actually, you all have it if you have Excel. So if anybody's ever used the Excel add-in for solver, and maybe it's a stats class at one point, or maybe you just got bored one day, but that add-in for solver, that's an optimizer. Theoretically, with a big enough spreadsheet and a large enough laptop, I guess, you could run your supply chain optimization with that, assuming you have about 5 products in 2 plants. The S&P version of that, I mean, they're all the same sort of principle, and there's other applications out there that do this as well. It uses the same principles, either minimizing a cost or maximizing profit to give you a solution that delivers your required goals. In this case, we're generally talking, and I would say, 90% of the time you're going to do cost minimization. There is a profit maximization engine as well. Haven't seen that personally used as much, so we're going to use least cost as one. But basically, it takes all these costs that you enter into the model, and that could be product storage, could be delay costs. We're going to get into all those later, but looking at the entire solution and every possible option is going to give you the least total cost. So the least cost for whatever problem that you're solving. Now, why would you actually need this thing? The heuristic gives me orders. It's orders to meet demands. I don't know why I would need an optimizer. The biggest issue that people solve with an optimizer is you have a very limited set of assets, right? Or very high demand signals. And you need to find out a way to minimize that total cost to your supply chain while meeting your stated goals. So if you have plenty of capacity and you don't really have any constraints on what you can manufacture when, optimizer is probably not a great scenario for you. Right? It's not going to give you too much benefit. It's going to give you the same answer that you're going to get with a heuristic, only it's going to take longer and it's harder to support. What you do need for is, well, okay, I have 3 assets that can make it for 9 months of the year. They're completely capacity constrained. How do I know how much to build when to provide the least total cost to my supply chain, balancing inventory, service, and production? And how do you use those lines? The way I usually describe this when I'm doing training is the optimizer is not meant to show you how to produce the cheapest product on the cheapest line in your supply chain. Anybody can look at a list of costs and figure that out. What the optimizer is really for is to show you how to minimize the most expensive product on your least efficient line in your supply chain. So minimize the impact, and how do you best utilize those assets that are, slower, or products that are more expensive to make or carry. That's really the best part, the best way to think about what an optimizer does and doesn't deliver. Again, it looks at inventory and service, and there's a whole bunch of levers we'll get into around, which to pull when and how do you get it to do what you're looking for. Just a little bit of technical background on an optimizer too. While it is part of an APO solution, it is a different license and it's different hardware. So while your planning books, your data views rely on live cache, this is actually a separate Windows server generally. And the short version how it works is that your APO engine will take the problem that you have developed for it, write a file, send that file off to a separate piece of hardware, being your optimization server. The optimization server will run its magic, and it'll send back another file, which the APO application will then interpret into planned orders or stock transports or the like. Okay. So it is not part of the standard base APO solution. There is a little bit of extra that you'll need to get it, but that's what it is. So the SNP optimizer, you know, if you mention this to probably 10 people that use it, you're going to get 10 different word bubbles above their head about what their interpretation of SNP optimizer is. The three main ways that I've seen it used is one for network sourcing. So take the all-in supply chain, show me all my transportation options, show me all my production options, run the whole thing in one massive plan, and show me the least total cost for the solution. That's a big problem, right? That is a big, large, difficult problem for any human being to do, to be honest, because there's no way to calculate the implications of everything, especially if you have multiple assets, multiple production, or multiple lines that can make the same product, right? So do I make it on this side or that side? Is it better to make everything on the West Coast and pay for the transportation, or do I make it closer to the customer and minimize transportation costs? Those are the type of network sourcing decisions that are made. These are big solves, right? If you think about how the optimizer is working, it's looking through every possible option of, do I source here or there? Do I ship it? Do I not ship it? Do I make it? What do I make? How much do I make? How frequently do I make it? Basically, every option available to it based on transportation and production gets thrown at a wall, and it comes back with the least possible cost for that solution. These are generally done in an offline version. You wouldn't want to do this live in production. That would probably kill your kill your MRP planners, kill your production planners, if their network reality is flipping 5 times a day. But the output of it is used to drive those actual production decisions. Another way I've seen it used is to just generally take the output of demand routed to a plant and then optimize production. So in this case, we're saying the demand is routed through a heuristic to a location based on quotas and transportation lanes. And the production plant gets a demand signal that it's responsible for produce. So now you can use the optimizer to say, okay, forget all external procurement options. I'm stuck with this demand. What's the most efficient way to make it? And in that way, you're just planning basically by line, by product group, but most likely by plant location. And that's going to help you to decide, you know, how frequently do I make it? What lines do I make it? How do I load my plant in the most efficient manner? And how do I plan? What inventory levels am I going to carry? Those kind of things. So that's what production will be used for. And the flip side of that is deployment. So I've got a ton of inventory. It's sitting in all different corners of the world. How do I get that inventory at the right place at the right time? And in that case, you're basically doing the opposite of the production optimizer to say, well, I got inventory over here, inventory over there. I don't have any options to make it. How am I going to deploy it so that it goes to the right spot at the right time? These are generally short horizon kind of things, especially if you're not allowing it to make anything. And it's a optimal redeployment of your current inventory solution. So it is flexible. It can do what you want it to. These are all kind of configuration and cost derived, and all viable business cases that you would use an optimizer for. So why would you ever want to use it? Why would you actually propose that your organization take this thing on? There's a bunch of different reasons, but I'll highlight a couple right here. One of them is, how do I react quickly to a changing scenario, right? So you have a demand signal that changes, either forecast is modified over the weekend or huge sales orders come in, and you're stuck with, how in the world am I going to meet this demand? All right, with those kind of problems, you can use an optimizer because it doesn't just give you an option, it gives you the mathematically best option. And I say mathematically best because if it was, there's always some human element that needs to go in there to give some rationalization behind it. But it will allow you to react quickly and intelligently to changes in your supply chain. So the kind of metaphor used, and it's just probably a hashed out cliche, but you know, a butterfly flaps his wings on one side of the world and creates a hurricane on the other, right? That's the possible kind of things that can happen in a supply chain where demand in one area, the least total cost to meet that demand might be some changes to a different scenario in different side of the country, different side of the world, and the optimizer will help you find those. Another real good use case is a way to manage seasonality for pre-build of inventory and campaigns. So if you have a product, say, I don't know, that's very popular around the holidays, or Halloween, let's use that. That just happened, right? So if you're making candy for Halloween, you know, you're making that candy in February to meet demand in October. So instead of just making everything all the time, what's the most efficient way to do that, right? So when do you want to change over? How long a run do you need? Managing that seasonality, not just to meet demand, but meet it in the most cost-effective way is a great use case for an optimizer. Okay. Especially that the next point is that it will utilize lot sizes, campaigns, setups, inventory constraints to give you an inventory production ahead of time. So you take that candy scenario, and guess what? The optimal solution is you don't have the storage space to meet it. You can go ahead, put storage constraints in, and work with the optimizer to give you a feasible solution that you can present to management to say, here's how we're best going to meet this demand, and here's the inventory costs you can expect for the next 9-12 months. The last good one is, it's not last, but it's the last on the slide, give me the least cost solution when multiple sourcing options exist. If you have products that can only be made at one resource possibly ever, then you don't have a lot of options, right? It's just how far in advance am I going to build it. If you have multiple sourcing options, so for example, if you have a plant or a product that's made in multiple locations, maybe it's real heavy or bulky to move, you can run the optimizer to provide that least cost solution to say, well, okay, where are the trade-offs? If I make the trick here is that it is a least total cost. So if you have office politics or plants that are very sensitive, you know, one plant might end up with a more expensive year than another, but the least total cost to the organization is what the optimizer is focused on. And that's another reason why people need to be involved, because you know, an optimizer is a mathematical calculation. You need to bring real-world constraints into it. So those are some good use cases where we've seen a lot of value. Again, the most bang for your buck when you do this is a capacity-constrained, low-margin business that have multiple sourcing options. So you have a limited set of resources. You need to maximize your output out of them, shrink your costs, and provide the least landed cost to your customers. That is a great option. If you have a really light, very high-margin product, and you can afford to air freight it all over the country to meet demand and still make your profits, well, you know, you're not going to see the value that you would, or at least it wouldn't be perceived as being as valuable as a company that has low margin, heavy, difficult to move products, right? Shelf life is another one. If you have products that expire, so think of foods, think of pharmaceuticals, that would be a good one. And to minimize the relatively high cost of transportation. As transportation goes up, you know, how do we make it? Do we make it on one side of the country everywhere, avoid changeovers and ship it? Or does everybody make it everywhere and we avoid transportation because we can't find trucks? Those are the kind of values that you're going to get from an optimizer based on the cost. So with that, there's a couple of polls here I think Megan can pull up just so we can kind of gear our conversation a little bit more. Focused on, you know, what kind of processes are you looking for? What industries you're looking at, and when do you want to implement? It's not, we're not trolling for sales. It's just a way to focus the discussion a little bit better and to say, you know, what industries are we talking to today? What networks are we talking to? And are we talking about people that have already done it or are just learning? So Megan will open this for a few minutes, and then Sanjay will dive into his part of the presentation.
Great, thanks, Mike. So if you want to just go ahead and fill in the answers there for whatever applies to you and your company or your client, that would be great. We'll get a few more answers here before we close this out. Looks like we've got a lot of consumer goods in the audience here. Let's give this about another 30 seconds. Perfect. And we'll go ahead and look at those results. And I am going to turn this over to Sanjay so that he can kind of tell us what we're looking at here and launch into his part of the presentation.
Okay, thanks, Megan. Okay, so hi everybody, this is Sanjay Jalaji. What we are looking at here, it looks like, like you said, Megan, quite a few consumer goods, and then it looks like there is some interest in trying to do this fairly soon. So, and then, yeah, what we've typically seen, the answer to question 2 as well, it looks like, it's always a kind of a mix of both, distribution and manufacturing. And there always are capacity constraints as well. So that's good to know. I mean, this is a 1-hour session, and it's for a topic that's as wide and as complex as the optimizer. There obviously isn't enough time to cover everything, but what we are hoping to do is cover as much as possible, and then hopefully we'll have some follow-on sessions depending on the response and the interest levels that we see out there. So, so with that said, let's go on with my part of the presentation, and then what you'll see as we go through this is we'll slowly, try and get deeper into the session, deeper into the details of, I guess, part of the solution. But keep in mind again that this is a limited session, so as much as we can, but then hopefully more to follow. Okay, hold on. Okay. Okay, so the section that I'm going to go through is essentially going to just talk through the different approaches you can take. Mike gave us a good overview of all the different use cases for trying to actually, when you make that decision to go the optimizer route. And then once you've made that decision, I suppose you still have to kind of consider how you want to put some sort of a boundary around it. So hold on, guys, while we try and get this to. Okay. Sorry, so we are having a little bit of a technical difficulty, but okay, so one of the things you can do as a starting point is, and this can be even before as you try and make that decision on whether you want to go the optimizer route or not, is to try and define your objectives, as a simple problem statement. It doesn't have to be a long, drawn-out, detailed objective, just something in terms of, what are some of your primary objectives from a supply chain standpoint. Take distribution, take manufacturing, take your constraints, and try and define that as a problem statement just from a planning standpoint. So now the second part of that, where I say that, if possible, try and do it as an abstract mathematical model. That's something that you may or may not be able to do, right? I mean, I think that's If you've got somebody who's got a PhD in mathematics and can define a problem statement like that, well, yeah, sure, go ahead. But I think it'll initially be more of a descriptive statement that you're going to try and define. So, and part of the way you can go about it is in terms of trying to draw some boundaries around what you're trying to achieve, is trying to answer a few basic questions, right? And this is just a few of the questions that that I've put down here. There are obviously more, but you can try and answer questions like these, right? So you can say, do we want to try and optimize the entire supply chain, or do we want to just do just a portion of the network where maybe we've got some huge constraints, and as long as maybe we can optimize what is maybe a bottleneck, or where maybe we want to really keep, where we really want to try and minimize costs, maybe we just want to take that part of the supply chain and do optimization around that. So, and with the optimizer, one of the things you quickly learn is, just some of the performance bottlenecks you can run into. So it's always a good idea to try and start small and then grow with it as you gain experience with the behavior of the optimizer. So some of the other questions over there, so what is the product mix that will maximize profits? What kind of a time horizon and time bucket do I need to consider for optimization? So in a lot of the industries, consumer goods and pharma especially, we've kind of seen scenarios where companies want to do this in weekly time buckets for 24 months. Well, you could probably do that in, maybe something like a linear run where you aren't really considering lot sizes. But then the moment you try and do something where you want to consider lot sizes and do discrete runs for that longer duration, well, you will be running into performance constraints. So part of trying to draw some boundaries around what you want to optimize is also, just the constraints of what the optimizer can solve. And in addition to that, not only what the optimizer can solve, but also what planners can really understand as they review and analyze the results. So, the larger piece of the network or the processes that you're trying to optimize, the more difficult it's obviously going to get to even analyze. So just keep that in mind as you figure out the approach you want to take. So so again, that the mention on lot sizes, just always keep that in mind. How far out do you really want to consider lot sizes? Typically, what we advise is you try and limit that to a shorter time frame instead of a long duration. And then the other thing from a performance standpoint you need to consider is, do you want to try, not only from a performance standpoint again, but also from analyzing the results standpoint, do you want to try and do it at an aggregate level, or do you want to do it, at the lowest level, lowest queue level or lowest location level? Because again, I think it's easier to understand and interpret the results as you try and analyze it. So just here are, I think what this and if you add a few more questions will kind of help you just gain some understanding on how you want to approach it. So this section is just kind of still talking about and extrapolates what I was trying to say earlier in terms of trying to define some boundaries, is how you want to take and consider the balancing of just quality of the solution that you're going to get and the time that it takes to solve. So, if you're going to solve something for a global network with time zone differences and you have only the weekend to do this, but maybe even less than a weekend, then how do you try and run this? And the doing it over weekends and doing it on a weekly basis or a monthly basis is the one thing, but then as you're doing your, like Mike mentioned, the advice is to try and do this in, simulation versions as much as possible. So if you're going to do it even in simulation versions, well, do you want to wait for, 10 hours, or do you want to just do it in a shorter time frame so that you can analyze, adapt, rerun, simulate again, and analyze the results to tweak either your cost model or what it is you want to include in your model is something that needs to be considered. So there are a few ways you can do this, so one of the ways is you can control your time buckets, right? So what you could try and do is try not to go to daily buckets for your entire horizon. Try and do a mix of weekly or monthly time buckets, and and the bigger you make a time bucket, the better the performance you're going to get. Trying to limit your location products and aggregating them either from a resource standpoint, a product standpoint, or a location standpoint. If you can do that, is always going to help. The thing to look out for with aggregation always is trying to figure out how you're going to disaggregate the results. And in our experience, we've kind of seen aggregation, but it is limited. Haven't seen it a whole lot, and part of the reason is just the complexity around trying to understand, trying to take the results and disaggregating them to where you can define rules around what, how you're going to disaggregate. So that's just something to keep in mind as you make those decisions. So this next section, as a part of again, trying to approach and manage some of these benefits, is trying to figure out whether you're going to use real or relative or actual costs. And Claudio is going to try and touch on this as well a little bit. The answer to this usually is, it's always relative costs. As nice as it sounds to try and use actual costs, trying to keep up with that and integrate it is too much of a hassle, is what we've seen. So, going the relative costs, what it lets you do is, you can come up with those estimates, and this is where you kind of need to make sure that you have the right people involved, right? So you not only need people in the planning organization that have information on, these relative costs that can be a part of this early phase of the design and implementation as you go about it, because the other ones, a planner understands maybe, the logistics of trying to move stuff around, and has some idea about, costs, but then may not get or know the overall picture. So you might still need somebody at a higher level of the planning organization to be a part of this conversation. And it's important to get the cost model right, just because that eventually is going to determine all the results that you're going to see and get. And being primarily a cost minimization solver, even though you can do profit maximization as well, I think it's it's a critical part of what you do. And half of trying to understand the results is making sure you understand the cost model. Otherwise, the results are just not going to make sense. As and the thing to keep in mind as you evaluate these results again is it's a total solution that you need to look at. And then the other advantage of you trying to use relative costs is you can manipulate that to drive certain behavior. Where maybe you want to, let's say, utilize, let's say, a push model. Well, you can go ahead and kind of do something where you're trying to distribute, where you're trying to push product out, so you can make the cost of storage very high at a certain location, and then use that to push product out. Okay, so linear versus discrete. I'm not going to go into this a whole lot, but suffice it to say that so the main thing with this is you'll end up trying to do if you're going to do lot sizing, and you do need to consider lot sizing, and that's part of the power of the optimizer. Is you've got to use the discrete model, and the trick over there is it is going to take, the moment you introduce discrete runs and lot sizes, the solver is going to take longer to get the optimum results, and you will be doing a lot of simulation to figure out what is an appropriate time frame to get a solution that is kind of acceptable. So it will take a lot of playing around to get that right, but that's something that will come with experience as well as several simulations. Okay, this next section, is just a guideline to kind of use to size your model. It kind of goes through just a brief summary of how you can kind of evaluate, depending on whether you're using a linear or continuous model or a discrete model, how you can try and evaluate the number of variables that you're going to work with, and this will help you benchmark your results as you go through it. So I'm not going to go through these. If you have questions later on, you can ask them at the end, or we can even you can send us emails as well later on. Okay. This next section is just talking about, the important things that you need to consider in terms of, skill sets that you need as a part of the implementation team, as well as, consultants that you bring on board to try and implement the optimizer. So things to look out for, past experience in what-if scenarios is an important consideration. You need business users and consultants with an eye for detail and an eye for getting into evaluation of logs and results that are very large and time consuming. So somebody who's got the skill set to do that is something that you definitely need. And then prior experience is almost a must. Okay, with that, I will let Megan hand it over to Claudia, who's going to do the next section.
All right, can everyone hear me okay? I hope so. All right, so it looks like I took over here, so I have the power to move my slides. So let's finish up the last few minutes here to talk a little bit about master data that will be needed to run optimization, the profile, the optimizer profile, and as well as input and result logs. And the reason why we want to cover that is because, especially if you haven't done the optimizer, there's always a lot of questions around, okay, well, if I want to do optimization, right, how much extra master data would I have to maintain, right, as a business? That's always a big question in any implementation. The good news is that there is not that much more master data that you have to actually use, right? If you take a look at this screenshot here, this slide, you'll see that you still have your location, your products, your resources, PPM or PDSs, and transportation lanes, which if you use heuristics or if you use CTMs in the past, you're familiar that you have to use those anyways. Where the optimizer comes in is that you have to start using all these costing parameters, right? Costing parameters that you wouldn't use in the other engines, right? So how many costing parameters are actually out there? Well, there's a lot of them, right? So here, and I don't think I have all of them here. There's tons of costing parameters that you have to maintain. Storage costs, procurement costs, you have shelf life costs. Now, as Sanjay mentioned in his previous slides, the idea is to start small, right? I would always recommend to start with maybe 1, 2 different type of cost parameters, and then based on that, figure out, understand what the optimizer result is telling you, right? Because the more costing parameters that you add, the more complex the solution is going to be, right? And here we go in a little bit into the actual versus relative cost. Actual costs, in my opinion, this is from my experience, first are usually hard to come by, right? A lot of actual costs, you may have to go to finance departments and get them. Sometimes that is, a very open discussion. Also, some of the costs are very hard to get. Like, if you think about delay costs, right? That's really a calculated cost, right? So you will have to have a whole discussion. Okay, how do we calculate this cost, right? So the idea is to try and use relative cost, but drive that behavior that you want the optimizer to do, right? And I guarantee you'll make your life a lot easier. So you have all the different type of costs. All these costs are maintained in different places. Now, SAP came back not long ago, and it gave us this transaction, the SNP, which is actually very handy because it allows you to maintain pretty much all the costs that the optimizer takes into account into one transaction. All right, so that's actually really nice to have, because even after you maintain those different costs, you can go back to the transaction and in one transaction figure out, okay, what are all the costing parameters that we actually have maintained. So the one thing to understand from a transaction really is that the most cost that you use, the more complex the model can be, okay? Which in simple terms, it turns that depending if you do a linear or discrete, as Sanjay mentioned, the performance can suffer, right? Okay, so let's go to the next one. So here what we have is, unlike heuristics, it basically just takes the data from the material master, from the product master. The optimizer really has a lot of levers, okay? The optimizer basically takes the optimizer profile to understand and figure out how is it supposed to run, right? And the optimizer profile, as you can see from the slide, it has a bunch of different tabs. We're going to go through a couple of them here. We only got 10 minutes, but let's go through the highlights. The top one here is you can define which constraints you want the optimizer to take into consideration, right? So we have production constraint, transportation constraint, storage constraints. What's good about this check marks here is that, let's just say you maintain transportation costs and all those costing related to transportation, you maintain it, but you don't want to take into consideration for a specific run. Well, you don't have to go and delete all those costing parameters. You can go in here and check this transportation capacity, and then the optimizer will just ignore it for that optimization run. So it gives you a good on and off capability. Another one here to take into account is the maximum lot size. Do you want the optimizer to take maximum lot size or not? So one of the things to understand is maximum lot size works with linear, right? It doesn't mean that you have to run a discrete model. And I had this question before. So if you think about minimum lot sizing, right? If I have a requirement of 100 units and my minimum lot size is 150, well, the optimizer now has to really go back and forth and say, okay, do I make 300 to fulfill the 100 requirement? Do I not make it? Am I going to be short? So it goes a back and forth discussion, right, within the solve. While maximum lot size, if you have a requirement of 100 and your maximum lot size is 50, the optimizer will say, okay, well, I'll just make your order to 50, right? It doesn't have to go back and forth to make decisions as much as if you do a minimum lot size. And that's why it works with linear. Safety stock, again, you can turn the lever on and off here if you want to ignore it, or if you want to take it into account. If you do want to take it into account, you have what we call the absolute and relative option. All that means is the absolute takes the quantity-based safety stock into account, and a relative takes a percentage of the safety stock into account. And then again, the same thing goes along with shelf life as well. Do you want to take into account, or you don't want to take it into account? All right, let me go to my next slide. The next slide, I'm not showing all the tabs here because I'll bore you to death, but the next one that I think is important is you have the discrete method type. And then in this section here, you can define for how long should the optimizer run a discrete. And this is really important, right? Because even if you need to run discrete because you have to do, say, a fixed or a minimum lot sizing, it doesn't mean that you have to run discrete for the whole horizon, right? So the optimizer allows you to say, okay, for how long, say, do you want to run a minimum lot size model? All right, so if you want to run it, say, for a month or 2 months, then you can define that here, and then what the optimizer will do is it will run discrete for the first 2 months, but then the rest of the horizon will turn into linear. So that would definitely help you from a performance point of view, that rather do that than running, discrete for, say, 24 months. So you will control that in the optimizer profile. Another good parameter to keep in mind, obviously, especially if you run discrete, and it was mentioned before either by Michael Sanchez, it has to do with maximum runtime, right? If you run a discrete optimization, what basically happens is the optimizers go to what we call iterations, right? It goes through a solve, it finds a solution, and then it does the solve again, tweaking parameters, and it finds another solution, and it tries to improve on that solution, okay? So what you probably should want to do is say, okay, let me run it open, see how long it takes, right? And then on the optimizer result, you'll be able to say, okay, it took, say, 150 iterations. But when you start looking closely, you'll see that maybe after the 99th iteration, the actual improvement is minimal, right? So the other 51 iterations is really so minimal that it wouldn't make business sense. So what you do is say, okay, how long did it take to do that 99th iteration? And let's just say it's an hour and a half. And then you would set that as your maximum runtime. Because you know that, hey, after 90 minutes, the improvement that I'm getting is not as much as it wouldn't really make a difference. Now, you got to be careful with this. If you do make big changes on your model, right, then you do want to understand how would that have an impact on your iterations, because then your iterations could take longer, okay? So, but if your model doesn't change, then you can put a maximum runtime, right? So you can either define it as in minutes, or you can say how many actual improvements, how many iterations do I want the optimizer to run. Okay. The other one that's important is, especially if you run discrete, is what we call decomposition. And in decomposition, what it does, it tries to improve in performance. And it does this by doing either a time decomposition, a product decomposition. And the way that it works is that the optimizer will then break the problem into different chunks. So it'll, for example, in a time decomposition, it'll break it down in buckets. In a product decomposition, it will break it down in a block of materials, and it will process those sequentially. So it's still doing optimization, and it's still doing it holistically, but it's able to break down the problem. And what that will help you at the end of the day, some performance improvement. Okay, and then quickly you have also, do you want to do a priority decomposition based on extreme prioritization, which is basically using priorities, or you want to basically be done through costing. And then the last one, and this, we always get this question, and even if you ask Matthias Gugelt, which is the optimizer expert up in Germany, they always say, which one should I use, Primo or Dual Simplex? And the answer is, you have to try both, and then see which one actually gives you the fastest results. From a result perspective, it should be about the same, but depending on how your model is set up, one of these two may actually run faster than the other. Okay, I know we're running quickly, so we have some quick Q&A. Let me finish up here. The other thing that we have available is something called the cost profile. The cost profile, some customer uses, some don't. Basically what this allows you is allows you to apply a different weight to different penalty costs. So when you first get the optimizer, you will see that everything has the same weight. So everything will be set as a 1. So you can go in here and by optimizer profile, you can say, okay, I want, by profile, I'm sorry, you can say, okay, I want my storage capacity to have a weight of 2. So that basically would mean that now you have a higher weight on that capacity, storage capacity, so that when the optimizer is calculating the cost, it will say, what's your cost times 2, right? So this helps in a way so that you don't have to go back and forth and maintain the individual costing itself. You can go in here and apply a different weight. The only caution that I have to this is that now you just added just one more level of complexity, right? Because now it's not just about the costing that you maintain, but it's also about the ways that I maintain the cost profile. So just be sure you're aware of whatever values you have here if you are going to use it. Okay. Okay. So the last couple of slides that I want to show you is, unlike heuristics, you have what we call the logs in the optimizer. We have the input log, which you see here. As Mike mentioned before, everything gets sent to an optimizer server. So before everything gets sent to the optimizer server, the system will look at all the parameters, it will look at all the master data, it will look at all the transactional data, and then it will put it into this input log, which is basically different types of tables. It's divided into the master data side and the transactional data side. One of the biggest advantages that you have with optimization is that you're able to manipulate these input logs. Not that we recommend it, but if you have a specific business scenario where you have to do that, then you're able to manipulate those input logs. Well, then when they go to the optimizer logs, the optimizer log will take that into account. And then on a bigger discussion will be, and we can do this in an off session, is we can use the input log and result logs to do simulation planning. There's a big enhancement that have been implemented in multiple clients where they use optimization to do on-demand simulation planning by being able to change on-demand the input logs. So if you're interested in that, we'll definitely have more information for you after the call. But that's basically what the input log looks like. When the optimizer is completed, it will spit out the results, and the result will come back to your APO server, and it will come back in the form of result logs, which is basically all your transactional data results, right? All the transactional data the optimizer created based on the results of the optimization run. And then the other log that you're going to have is your actual costing log, right? The optimizer will tell you, okay, so this are all the costs that will actually incur, and it will break it down by specific area, and then it will also give you a total cost. Okay, so those are the 3 different logs that you want to keep in mind. You want to keep in mind your input log, your result log, and your costing log. And then finally, I don't show it here, but see that solution quality there? That's where, if you're running Discrete, that's where we show the number of iterations that the optimizer actually went through. Okay, and again, it was very quick. It was only a taste of the, of the optimization, but we only got an hour, and now we only got 5 minutes for Q&A. So this completes my section. Thank you. So back to Megan.
Yeah, so what we're going to do is just go into the Q&A at this moment. I know we don't have a lot of time. I know that, let's see, Harsh Singh, I think, Harsh, you kind of had a question that that says how we can use the cost minimization functionality in SNP optimizer. Claudia, do you want to try and take that on? So it's just basically saying, how we can use cost minimization in the SNP optimizer.
I don't see the question, but okay. So cost minimization, right? From the optimizer profile, I'm assuming. Let me hold on. Give me 1 second.
Pull up your Q&A.
Okay, hold on.
Window.
Give me 1 second. Yeah, I think I see it now. Let me read it. Well, the cost minimization is really the default, right? So that's the one that you actually run. Usually, most of the clients run, right? The cost minimization model, which is basically the model. It will look at all your overall cost and it will try to minimize it, right? What we haven't seen used a lot is the profit maximization. That one I haven't been on any client that used that one. But the cost minimization, again, it's just basically what we talked about today, right? Is maintaining your parameters, and then the optimizer, based on all the costing that you have defined, will try to minimize the overall total cost. The thing to understand is that it will try to minimize the overall total cost, right? So that's what the cost minimization means.
Okay, thanks, Claudio. So
yep.
If there are any other questions, go ahead and post them.
I think we got an effort one, yeah.
It looks like there's one on how much effort is required to implement the optimizer, IT, and business. The way I usually answer this question is that it's fairly easy to get a solution where all the lights turn green. It's fairly difficult to make to get that solution that turns green that's usable. So that's where the issue comes in. It is some significant business input because, like I said, you can get it to turn green, but if it gives you a solution that's infeasible or you have data that prevents certain decisions from being made, it's not going to be much use to the business. So I would suggest a bit more business than you would think offhand, just so they can provide the input into what they want the optimizer to do, and more importantly, what it can't do, so you can get a solve that is actually usable. From the IT side, I mean, there's some people do custom objects, there's some custom stuff you can do the input, but overall it's mostly config and having somebody that understands.
The only thing I would say from an implementation point of view is that obviously it all goes down to how big the model is that you want to implement, right? Because at the end of the day, what differentiates it from the other engine that SNP provides is the optimizer tuning, right? The tuning the optimizer so it comes out with the result that the business wants takes time, right? I always say that depending on the type of implementation that you do, I wouldn't give it less than 6 months just to do the tuning alone, because otherwise a lot of customers come back to us and say, oh well, the optimizer doesn't work, but it does work. But the thing is that it's just not giving you the results that the business wants because we haven't tuned it correctly. So that's, to me, that is a big thing that needs to be called out. And I think that's another question here. Does it make sense to use deployment optimizer after S&P optimizer? Anyone wants to tackle that one?
Yeah, I can take that on. So that's a good question, actually. So that's we haven't seen that being, in at least my experience, I haven't seen that being done a lot. Because keep in mind that the SNP optimizer, when you're running it, is kind of doing deployment for you as a part of, based on your cost model. So you generally don't see that, but it is an option that's still available where maybe you want to kind of get the overall picture and then maybe override the results and still use the same cost model to just do deployment on its own. So
right?
Right.
And then the deployment optimization, what I've used it in the past in other clients is they didn't use it so much from a production push-out point of view, but they used it from an inventory network balancing point of view, right? They had inventory all around multiple distribution centers across the United States, and they wanted to be able to optimize the inventory between the distribution centers before they kick off any type of production. So that's how the deployment optimizer was used in that location.
Great. I think that's about all the time that we have for questions. If you guys want to stay connected, we are on all of the basic social media platforms. We're active on LinkedIn, blogs, Google+, Twitter, and Facebook. And thanks to everyone who came today. If you do have any other questions, you can always check out the resources that we have on our website, scmconnections.com. If you have any remaining questions, feel free to shoot us an email, info@scmconnections.com, and we'll make sure that that gets to the right person. You will get the link to the recording on Monday in case you want to watch it again or in case you want to send this on to a colleague. But otherwise, thank you so much for attending, and be sure to check out our upcoming sessions.